Okay, welcome everyone to today's webinar. The webinar title today is Examining the Role of Canola Meal in the Diets of Early Lactation Cows with our featured speaker, Dr. Kenneth Kalscheur of the USDA Dairy Forage Research Center. Okay, so quickly to introduce myself. My name is Brittany Dick, and I work with the Canola Council of Canada. And welcome everyone. As I said before, this is our final webinar in a series of 3 webinars that highlights canola meal as a protein source for dairy cattle. Now, the Canola Council of Canada is really quite pleased to be working with AMTS in partnership in effort to extend research findings and the practical application of these research findings to the dairy industry. I'd like to really thank Marian and her team at AMTS for working with us on these series. It's been very, very excellent to share this experience. Research is a priority of the canola industry, and I want to emphasize that. We have significant resources that we direct towards research and research institutions in North America and part of that research is to really fully examine canola meal as a protein source for dairy. The results of this research to date have really brought to light the value that canola meal brings to dairy rations. And we really hope that this webinar series brings you some new insight to your dairy rations. At the end of the webinar, there will be a slide that will link you to the AMTS page where the other webinars are also held there. So if you want to go back and view some of the other webinars, you can do that. So I'd like to start the presentation today actually introducing Dr. Essie Evans. So Dr. Essie Evans is going to carry us through a few slides, and then we are going to pass over to Dr. Kenneth Kalscheur so that he can then share his research with you. But firstly, I just want to highlight Dr. Essie Evans, and she has been a very key player in guiding canola meal research and sharing that research with industry. So just quickly here to introduce Dr. Evans, she grew up in Baltimore County, Maryland. She earned her BS degree in agriculture from the University of Maryland, moved to Ontario, Canada, and attended the University of Guelph, where she obtained her master's and Ph.D. in animal nutrition. Essie began her career in industry where she joined the research and development group at Canada Packers, now Maple Leaf Foods. And one of her areas of specialization is mathematical modeling, and she led in the development of models for dairy, beef, swine, and poultry. She has achieved the level of vice president and managing director with Suregain, the feed division of Maple Leaf Foods, while continuing to work on her research. And then in 2002, Dr. Evans started her own company titled Technical Advisory Services. And this company provides technical and managerial support and assists with research and product development to entities requesting such services. And Dr. Evans has worked closely with myself at the council since 2014. And we're going to share her slides with you now. So Dr. Evans, if you can unmute your mic.
Okay, well, thank you very much. The past 2 talks in the series, we've had some great questions, and a lot of the questions centered around the amino acids and their contribution from canola meal. So what we decided to do was just to take a few minutes and maybe discuss that separately from Dr. Kalscheur's talk. And what I've done here is pull out values out of the AMTS.cattle program out of their base library using CNCPS technology to compare some of these proteins. And on the first line, we have canola meal at 41.5, soybean meal at 51.5, and corn DDGs at 30.3% crude protein. Now, that doesn't really tell all of the story, because if you go down to the next line that shows the RUP of the crude protein, you can see that both canola meal and corn DDGs have considerably more of their protein fraction as RUP than does soybean meal. So when we then go through and calculate how much of the meal on a meal basis is actually RUP, you can see that canola meal has more than soybean meal, and corn DDGs, even with lower protein, has pretty close to what soybean meal contributes. Now, this is untreated soybean meal. Now, to be fair, the RUP digestibility really needs to be taken into account, and that is lower for canola meal than it is for soybean meal. And if we take that into account, then for each kilo of the meals, you look at the bottom line, the digestible RUP is the same. So we get just as much digestible RUP from canola meal as we do from soybean meal. We have somewhat less in corn DDGs because, of course, it's lower protein product. Next, please. Now, basically, I think we've all been told that microbial protein is an ideal source of amino acids for dairy cows. So what I've done here was put up the amino acid profile out of the AMTS program, comparing microbial protein from a recent publication with the profiles for canola meal, soybean meal, and corn DDGS. And we can see that canola meal has about the same amount of methionine, and corn DDGs does as well, but soybean meal is lower. When we compare the lysine, we can see that the contribution from canola meal is less than that from soy or microbial protein, whereas with corn DDGs, it's very low. And we can go down the list here and just look and see that canola meal stacks up fairly close to microbial protein. And basically a lot of the research that's been done on the amino acids suggests that canola meal is closer to an animal protein or a microbial protein than most other vegetable proteins are. And that might be one reason why we're seeing some of the performance enhancements that we see with the ingredient. Okay, now on this slide, we would like to sort of compare the amino acids that you get when you feed 1 kilogram of each of these products. And so what I've done here is we've already said that if we have canola meal and soybean meal, we have the same amount, basically 156 grams of digested RUP, or available escape protein, and corn has less because there's less protein. So in the last column, to be fair, what I've done is prorated the DDGs to provide 156 grams, just for a better comparison. But basically, if we feed 1 kilo of each of these, you would get those 3 center columns. So the same amount of microbe or escape protein, but canola meal provides more methionine, 3.29 grams compared to 2.03 than soybean meal, and DDGs has less unless you put it on a prorated basis, then it's fairly similar. Interesting, soybean meal gets promoted a lot because of the high lysine contribution, but really on a 1 kilo basis, you're only getting 1 gram more lysine with soybean meal than you are with canola meal, 8.53 versus 9.52. Unfortunately for DDGS, you see that it has very little lysine, so it sort of falls off the map and becomes a bit of a problem in that area. The other 2 amino acids that are sometimes suggested as third limiting are threonine and histidine, and you can see that canola meal provides slightly more threonine than soybean meal, not a lot, but a little bit, and really excels in the histidine department. 5.7 versus 4. So the canola meal provides approximately as much digestible RUP as a kilogram of soybean meal. And that's not obvious from the amount of protein in the two meals. What soybean meal is providing with the extra 10% or so is more, or DP, more rumen available nitrogen. But really, as far as amino acids to support the cow and milk production, we're getting the same amount from both sources. The amino acid profile of canola meal is close to microbial protein. We have a little bit more methionine and histidine, but it's somewhat lower in lysine, so that might be something that needs to be supplemented. The amino acid profile of the RUP from canola meal might have advantages over soybean meal and corn and other vegetable proteins, and some of our research seems to bear that out, and I think the information that you'll see from Dr. Kalscheur will also point that out. Next, please. Just a little bit about models and what we do understand. We have some really, really great models that help us a lot in our decision making and in feed formulation, and I think that the CNCPS probably excels and leads the pack in that regard. But the models are never 100% complete. There's always factors that really you can't take into account mathematically that happens biologically. And right now, there's some aspects of metabolism that we really don't take into account or can't with the models. Like, for instance, there's uses of some of the amino acids that have nothing to do with protein synthesis. Methionine, for example, may be used as a methyl donor. There's interactions with glucose requirements, and sometimes glucose requirements are high, and we have to use amino acids to synthesize glucose in cows. So that affects the requirements, and it affects the amino acid availability for these cows. If, for instance, you need to have a high demand labile protein, you might have to synthesize non-essential amino acids to build that protein, and a source of them is often essential amino acids. So, you know, those are things that aren't really taken into account, and it provides some of the differences that we see that we really can't account for. Whatever the reason, canola meal seems to have an amino acid profile that's very well suited to the needs of dairy cows. And I think that Dr. Kalscheur will elaborate on that next. Thank you.
But thank you, Essie, for walking us through that. And we are going to now pass over to Dr. Kenneth Kalscheur, who's going to share his research on canola meal with us. And so I'm going to introduce Dr. Kalscheur before I stop sharing my screen here and we do a passover. Dr. Kalscheur received his Bachelor's of Science degree in Dairy Science from the University of Wisconsin-Madison, and his master's and Ph.D. degrees in Animal Science from the University of Maryland. From 2001 to 2014, Dr. Kalscheur was Professor of Dairy Science at South Dakota State University. Since 2014, Dr. Kalscheur is a research animal scientist at USDA Agriculture Research Service, USDA Dairy Forage Research Center in Madison, Wisconsin. Research conducted by Dr. Kalscheur includes utilization of forages and agro-industry co-products in dairy cattle diets to improve milk production and nutrient utilization by dairy cattle, and the environmental impact of animal management and feeding practices in dairy production systems. During the past decade, he has extensively researched how canola meal can be formulated into lactating cow diets. And so welcome, Dr. Kalscheur.
Good morning, everyone.
Morning. So I'll stop sharing my screen and you can take it over.
Great. All right, that looks good. Let me see if I can quick bring up the presentation. Is it up?
Yes, it is.
Super. It actually worked. Okay. Well, greetings from Madison. It's a nice, bright, shining morning, which is good if you want to put up hay or alfalfa. Thank you all for tuning in to this webinar, and thank you to the Canola Council of Canada as well as AMTS for putting together these seminar series. And hopefully we'll talk about some useful and interesting information that people can use. So I'm number 3 out of a series of 3 presentations, and I thought the 2 previous presenters did a terrific job in explaining aspects of feeding canola meal. So my tact on this last presentation really is to focus maybe a little more narrowly on the use of canola meal in early lactation cow diets. So my outline is fairly brief. I'm going to just briefly talk about the nutrient composition comparison, primarily between soybean meal and canola meal, and supplement what you just heard from Essie. I'm going to talk a little bit about what we've seen when we put canola meal in dairy cow diets, on dairy cow performance, in mid-lactation, high peak diets, those types of things, just very briefly, because that's really been covered really well already previously. And then the focus of my presentation today is going to be on some of my own experiences of using canola meal in early lactation. So nutrient composition, thought Essie covered very well. I just want to supplement that just briefly. We formulate really anything into diets. It's really important to have accurate nutrient composition data to understand what we're feeding. And so, for example, I think all of you are pretty familiar with some of these basic values. For example, crude protein, we all know soybean meal typically is around 50, 51, 52% crude protein, depending on the type of meal and where it was grown. My experience is in South Dakota, we had soybean meal that was locally grown that usually was around 48 to 50%, whereas if you get into Illinois and Iowa, crude protein is often higher in soybean meal. So it does vary somewhat geographically, so it's important to understand the soybean meal and all feedstuffs that you're feeding in your diets. Canola meal, nowadays, a lot of the canola meal that we're getting and using is typically above 40% crude protein, 40, 41, even 42%. Interestingly, if you look at some of the databases, the older databases, you'll see lower numbers for canola meal, 38%. It was pretty common. So be aware that these values can change. Another interesting aspect about canola meal is that there is a fair bit of NDF in canola meal compared to soybean meal, and these are values that I'm presenting out of various publications, and these values do change when you look at other references. But typically, canola meal will be in that 25 to 30% NDF range, and soybean meal is often in that 8, 9, 10, 12, 15% range. Ether extract in this case shows fairly similar, although I will be the first to say soybean meal, if it's solvent extracted, will be less than 1%. Most of the canola meal that I am using is typically in the 3 to 4% range. Certainly how the oil seeds are processed has a big impact on what the fat content is. And in this case, ash is very similar between the two. Essie covered amino acids very well, so I'm not going to dwell on this. These were actually values that we obtained from one of our own studies, and they really parallel quite similarly to what was just described. But I think the thing that always gets pointed out is that, methionine is typically greater in canola meal compared to soybean meal. And this actually has an impact when we're looking at the ratio of lysine to methionine. So if you look at the last column, and this is simply the ratio of the lysine methionine reported in the middle of the graph, and we can see that soybean meal has a ratio of about 4.7 to 1, whereas canola meal is around 2.8, 2.9 to 1, which is very similar to the requirement of the high-producing dairy cow, which is one reason why I think canola meal fits very well into dairy cow diets. Now, just talking briefly about amino acids themselves, we put a lot of emphasis on both lysine and methionine and ratios and amounts. And we made a lot of advances in understanding how we can go about doing amino acid formulation for high-producing dairy cows. And canola meal, has that more ratio that fits very well in the diets. I think that makes it easier to formulate and also helps with a number of different aspects when we're actually trying to balance rations. If we look at past research, we made huge advances, I think, in amino acid formulation in the last 20 years. And, there has been a lot of great studies that have demonstrated that formulating diets for amino acids in that pre-calving to postpartum period results in a positive milk yield. In this example by Garthwaite and Liu, I'm giving some examples where milk yield increased 2 to 2.5 kilograms per cow per day. We saw an increase in milk protein yield of 112 grams per day, as well as milk fat yield can also increase, which is typically an indicator of increased milk production. And there's a number of theories on why this is very useful in the peripartal period. And one thought is that the increased methionine in early lactation increases glutathione and the carnitine concentration in the liver, and therefore increases the beta oxidation capacity and the antioxidant prevalence. So increased methionine can be really important. By supplementing, we can affect methyl donors such as S-adenosylmethionine and also improve the antioxidant glutathione availability. There's been some really great research that has investigated that. So knowing that there is an increased liver inflammation in the transition dairy cow, the question is, can we meet the demand of these amino acids in a more appropriate ratio? And can we do this with canola meal? Also, during this time period, we know that dry matter intake is low. So if we're formulating for a more exact amino acid need, can cows be more responsive in supply when we're supplying more methionine through feedstuffs? Will the cow be more responsive, such as in early lactation? Now, this is unrelated to canola meal, but is related to the supplementation of methionine in early lactation. There's actually been quite a few papers that have investigated the supplementation of methionine during this period. I'm listing 4 papers here, and there's likely some more. And in this, the first 3 that all came out of Illinois, and the first paper by Osterio really demonstrated that if you fed sources of methionine in that periparturient period, and in this case, minus 21 days before calving and up to 30 days after, they saw improvements in dry matter intake, improvements in milk production, as well as milk composition, primarily milk protein percent and milk protein yield. They followed this up with 2 additional studies. The first one by Zhao was very similar in design with minus 21 and 30 days. And they also saw improvements in, very similar to the first study, improvements in dry matter intake and milk production, as well as component yield. The third study, also of the Illinois group, is Batistol. And in this paper, they also supplemented a different source of methionine and also saw increases in dry matter intake, a very good response in milk production and milk component yield. Now, just to show that all these studies are not just out of Illinois, there's an additional study that Dr. Evans found out of Turkey, And this study was minus 21 days to 21 days post-calving, and fewer animals on the study, but they still saw an increase in dry matter intake, an increase in milk yield, as well as milk components. So there is a building amount of evidence to show that feeding additional methionine or balancing diets to meet these amino acid requirements during this period prior to calving and post-calving has real implications on production results. And I'll get into why that can be important when we talk about some of the studies that we've done. All right, so the second point is effect of canola meal on dairy cow performance. I just wanted to kind of give a very brief background on some of the studies that have been done. I think Dr. Fasciola did a terrific job explaining some of the studies he's conducted and others on feeding high production dairy cows. So the majority of the research, if you go through all the literature, by far, the most of it is done on cows either at peak production or mid-lactation. And in some ways, early lactation, but not necessarily through the transition period. And through the transition period is really where we can make some long-term effects through the entire lactation. So we want to set the cow up well by feeding her correctly during the transition period in order to have a great full lactation. So if you look at the literature, and in this case, since there's lots of studies, I'm going to really focus on two meta-analyses that I think were referenced in earlier presentations, but I'll just briefly talk about these. The first one was published by Huhtinen in 2011, and the title is Evaluation of Canola Meal as a Protein Supplement for Dairy Cows, a Review and Meta-Analysis. He scoured the literature and found 122 studies, which was a great number of studies, including 292 treatment means. Now, I think in this particular case, they included a wide, vast array of studies from all over the world. And so they were not super selective. So there was, in previous presentations, we talked about rapeseed versus canola meal. I suspect in this study, all of that was included. And they did actually find some interesting results. There were improvements. If you look at all these studies together, there are improvements in dry matter intake, quite dramatically actually, like 2.6 kilograms per day, as well as increase in milk production, also quite dramatic. It looks like about 3.6 kilograms per cow per day. If you express that on an energy-corrected milk basis, there also was a very similar increase. And this is primarily to improvements in milk yield. If you look at fat and protein, you can see that the yields of fat and protein were actually non-significant. So the majority of that improvement was through increased milk and probably the percentage of the components. So the authors here concluded that canola meal can easily be successfully substituted for soybean meal on an isonitrogenous basis. And they also felt that most feed evaluation systems overestimate metabolizable protein of soybean meal relative to canola meal. Or I would probably also put out there that canola meal was underestimated. And I do feel that way in some of the older programs. Canola meal was probably not given full value. The second meta-analysis, which came out a few years later, was from Martineau, and this was published in Journal of Dairy Science. They were more selective in the studies that they chose. They picked 27 studies with 88 treatment means. And in this particular case, they compared canola meal to substitution of other protein sources. So there were a wide array of different protein sources, not just soybean meal. And in most cases, the comparisons were to all of the protein sources together, so canola meal versus everything. But in a few selected instances, they did pull out soybean meal so they could compare canola meal to soybean meal, and I'll just briefly talk about that. So these were the main results that they saw. And in general, and I think this is true with a lot of the studies when you read canola meal now, you know, the studies that are published, is that you see slight increases in dry matter intake. In this case, over all of the studies, they saw 1/4 of a kilogram per cow increase per day. This is not compared to soybean meal, this is over all of the protein sources. And similarly, as a result of this increased dry matter intake, milk yield also increases about 0.6 kilograms per cow per day. And that's really in line. If we think about increases in intake, typically results in improvements in milk are 2 to 1. So if we see a 1 unit increase in dry matter intake, that is often followed by 2 unit increase in milk yield. And this is similar to that. We also saw increase in 4% fat corrected, or in the case of 4% fat corrected milk, there was an increase when comparing canola meal to all protein sources. But when comparing strictly to soybean meal studies, there was no difference. So I have a few scenarios here where I'm pulling out the soybean meal results. In the case of milk protein yield, there was a 26 gram per cow per day increase when looking at canola meal versus everything. But when you look at just soybean meal, there's 16 grams per day compared to 32 for all of the other sources. So canola meal does well against all of the protein sources, and it still does well against soybean meal, but probably to a slightly lesser extent. In the case of milk fat yield, there really was no difference between canola meal and soybean meal, but when you look at canola meal versus all other protein sources, there was a 24 gram per day difference. And then feed efficiency, which can be defined as energy corrected milk divided by dry matter intake, there was really no difference between canola meal and soybean meal studies. However, there was an improvement when comparing to all of the other protein sources. So I think this meta-analysis did a really nice job kind of summarizing all of the various studies that have been published, indicating that, you know, when you're looking at similar types of studies, there are some advantages of canola meal versus other protein sources. So after those studies came out, I kind of looked through the literature and found that there really was very little, really no research done on the use of canola meal specifically in early lactation to see if there was an impact on feeding specifically canola meal versus other protein sources during that transition period and into early lactation. And for one reason why there probably is very little studies published in this area is they're not easy to do. I mean, they take a lot of effort, a lot of resources. You can't put all the cows on the study at the same time. You have to start cows as they calve, or even before they calve if you're doing transition work into the dry period. So it takes a long time to get sufficient numbers through, and there are challenges. For those of you who've done research, I think you can understand those scenarios. However, I did feel like it was really important to really investigate this area. And when I moved from South Dakota State to here, this was actually one of the first studies I did where I wanted to focus on the use of canola meal in early lactation. And so to do this, at the time, I really wanted to focus on the effect of protein source. And we also did investigate, you know, protein level, which I'll explain a little further. But we wanted to determine if the protein source had an impact in early lactation on production and whether utilization of body reserves had an impact when we're looking at canola versus soybean meal as the primary protein source. So one of the first studies I mentioned when I came to the U.S. Dairy Forage Research Center, and I'm like, okay, here's my opportunity to use a lot of cows. So my goal was to have 20 cows per treatment. And we did start 80 cows and 1 cow left the study. So we had 79 cows. and we used all multi-paris cows, so the average parity was 2.7. So this was a randomized complete block design, which simply means we had two cows were assigned to the treatment in sets of blocks by calving date, and they stayed on that treatment for the entire study. It was a 2x2 factorial arrangement, which I'll explain in a minute, but two sources and then 2 protein levels. All cows received the same diet for the first 16 weeks of lactation. So we did not do anything in the dry period. In this case, all cows received the herd dry diet, and so it was the same for everybody. And then after calving, within a day, they were assigned treatments. Cows were milked 3 times a day and individually fed in a tie stall barn. All right, just a little bit about the diets themselves. Whoops, let me go back one. There we go. I like to show diets so you really have a good understanding of my explanation when I'm talking about what kind of results we're seeing. I think everything really goes back to the diet, how you formulate the diet. So when you really are reading papers and evaluating the results that you're seeing, you have to fully understand what was in the diet, because it always goes back to the diet. So in this particular case, we wanted to keep things very similar across all diets, all 4 diets, with the exception of altering 2 factors. One is protein level. So across the top of this chart, you'll see low, which those diets were formulated to be around 15.5 to 16% crude protein, and the high protein was around 17.7 to 18% crude protein. So we had 2 protein levels that were about slightly more than 2 units apart, and then this difference in protein were coming from 2 sources. We have soybean meal and canola meal. So CBM is soybean meal, SBM is soybean meal, CM is canola meal. And you can see when you're looking at the diets, almost everything stayed the same with the exception of 3 ingredients. We had canola meal, and we had soybean meal and soy hulls. And what's really great about these types of diets is that you can get to the same protein level by simply diluting some of the soybean meal with soy hulls in order to basically equal the crude protein level of canola meal. And also by adding soy hulls, you get to a similar NDF level. I think the NDF digestibility is also somewhat similar. NDF digestibility of soy hulls is very good, but I think canola meal is also decent. So what happens is you have 2 diets that are actually pretty similar, with the exception of things like amino acids. They're obviously going to be different. So if we look at the low crude protein diet, we had canola meal in at 11.9%. And then in the soybean diet, we simply added a combination of soy hulls and soybean meal. And we still needed some soybean hulls in the low crude protein diet to dilute the diet so we could get at around 16% crude protein. However, if we look at the high protein level, you can see that there's no soy hulls or soybean meal in the canola meal diet. And we're feeding pretty high levels of canola meal, 19.4%, in order to get to about 18% crude protein. And then the soybean meal diet also did not have any canola meal, and we used primarily soybean meal and soy hulls. All of the other ingredients stayed the same. So it really came down to looking at canola meal versus soybean meal in these particular diets. I think as I mentioned earlier, it's really good to understand your diet. So these were the 2 canola meal and soybean meal that were used in the study. And typically when I try and do studies like this, I try and purchase all of the main ingredients up front so that we don't have to deal with any unexpected nutrient composition changes. So in this particular case, I think I brought in like 30 to 35 tons of each of these in order to complete the study, which took about 9 months to do. And so you do see some differences when you're looking at nutrient composition. I mentioned soybean meal is often like 51, 52. Well, in this particular case, then when we analyzed it, the soybean meal in this case was around 49%. So, and in canola meal, 40.5. So with this knowledge, you can formulate your diets to have an accurate formulation with comparison. Certainly on the farm and even in research settings, ingredients do change and nutrient composition does change, and that does pose challenges, but we have to do our diligent best to understand what those nutrient compositions are and try and control any variation, especially in a research setting. Now, I understand on the farm that real life is much different and that nutrient composition changes, and we have to deal with that. But I thought I'd put this up just to show you these were the actual composition of the two ingredients of test. NDF in this case, canola meal was around 24%, soybean meal around 7%, 8%. Starch, neither is very high, I mean incredibly low. Fat, this is very typical what I see. Canola meal is typically around 4%, somewhere in that 3.5% to 4%, 4.5%. Soybean meal, if it's solvent extracted, will often be 1% or even less. Ash is similar. You can see by NFC, there's actually a bit more in soybean meal, but more fiber in canola meal. So if we look at the actual nutrient composition of the diets, these were actually analyzed results. You can see crude protein ended up being slightly higher than where we formulated. It was between the two diets around 16.2%. And in the case of the high protein diets, they were around 18%, 18.1%, with slight differences between soybean meal and canola meal. You can see NDF was similar within the two protein levels, around 31% for the low and around 27.5% for the high protein. Ether extract was balanced to be similar across the board, around 4.5% to 5%. Again, starch also was balanced to be the same. And really, I mean, if you think about the diets themselves, none of the things that altered starch really were changed. So corn was the same across the board. Corn silage was the same. So these all came out to be around 27.5%. There's just a little bit of variation simply from sampling and measuring those types of analyses. And also ash was very similar across the board. Now, I want to focus some of our results. This was a big study for us, 80 cows, and it took us over 9 months to complete. So every cow 16 weeks, but because cows are calving at different times and we're only using multi-paris Holsteins, it took us about 3.5, I don't know, more than that, maybe 4.5 months to calve everybody in, and then to do a 4-month experiment. So let's get to some of the results we saw, which I think are quite fascinating. So the tables are going to be laid out very similar to what I just described. We're going to have low protein, high protein across the top, and then separated by the source, which is soybean meal and canola meal. And then if you look to the far right-hand side, CP, so the p-value section, whether or not something is significant. The crude protein, CP stands for crude protein, so that's protein level. So that would be low versus high. And then S stands for source, which is looking at the statistical difference between soybean meal and canola meal in the diet. And then CP times S would tell us whether or not there's an interaction between the level of crude protein as well as the source. So first one up, dry matter intake. Dry matter intake, really important in really all nutrition studies. And these numbers that I'm showing you are really, these are over the entire 16 weeks. So from day one of calving through the 16th week. And these are averages across all of that. And they're actually LS means across the entire study. So as we often see in most studies, there was an improvement in dry matter intake for cows fed canola meal. And the main effect is source. Canola meal cows ate about 0.8 kilograms per cow per day more than cows fed soybean meal. there was no protein level effect, and there was no interaction between protein level and source. On average, cows were eating about 25 and a half kilograms per cow per day, which I think obviously when cows first freshen, they're less than that. And then by the time we get towards the end of the study, they're probably in that 28, 29, 30 kilograms per cow per day. In fact, the next slide shows the graph over time. And so I think this was a really interesting graph. 4 diets. The blue line is a low protein soybean meal diet. And that blue, hopefully everybody can see the colors. The blue line is on kind of the bottom of this group. The red line with squares is the low protein canola meal diet. And interestingly enough, those cows took off right out of the chute and really separated themselves from the pack and ate extremely well through the experiment. The green triangle line with triangles is the high protein soybean meal line, and that's really kind of in the middle of the pack. And then the last one with X's and also purple is the high protein canola meal line. And that also is in the middle of the pack until we get towards the end of the study, which around the 13th week, it kind of separates itself and is greater intake than all of the rest. And if you're looking at the purple line and the red line, which are the 2 canola meal lines, you can see that the average of those two together are going to result in an increase in intake compared to the other 2 diets, which were formulated with soybean meal. I think in general, these increases are pretty normal looking, but I think the thing that really sets itself apart is that the low protein canola meal diet, those cows really separated themselves from the rest of the pack and did extremely well in that stretch from about week 2 out through week 9, 10, and then everybody else kind of caught up after that. Now, what is the impact of that increase in dry matter intake? Well, here's the thing. Cows milked extremely well, and consequently, the cows fed canola meal ended up milking 4.45 kilograms per cow per day more than cows fed soybean meal. This was highly significant. And crude protein level, if you're looking at the absolute values in this table, were not significant. So it did not matter if cows were being fed the 16 or the 18% crude protein diet. And there was no interaction between protein level and source. But 4.5 kilograms per cow per day is a lot. And this is over 16 weeks. And you can see production level, these are averages of the 16 weeks. All the cows averaged over 50 kilograms per cow per day, with the highest group, the canola meal high protein group, at 56.5 kilograms per cow per day, which is great, really terrific. And then if similar to the last graph, if you look at milk production over week of lactation, you can see that the red line and the purple line, which were the canola meal fed diets, really separated themselves from the soybean meal diets really quite early. By week 2, they were separating, and you could see a pretty strong gap of about 4 to 5 kilograms from week 3 all the way out to weeks 11, 12 with both of those diets. The low crude protein canola meal diets kept up with the high crude protein canola meal diets very well until about week 7 or 8, when they pretty much leveled off, whereas the cows fed the high protein crude canola meal diets really kept increasing all the way up to a peak at week 13, which is really quite late. But those cows were just doing great. If you look at the soybean meal diets, they also did very well, but they just peaked at a lower value compared to the canola meal diets. And they also leveled off and really stayed at good production for the entire 16-week study. So you can see nobody really dropped off dramatically after weeks 10, 11, 12. I mean, they all pretty much, they kind of hit their own peak, their lactation peak, and really stayed relatively flat through the rest of the experiment. Now, if we look at some of the other things that we recorded in production measures, fat corrected milk, This is taking into account the fat percentage that the cows are producing. Very similar to milk yield, we saw almost a 4 kilogram per cow per day increase for cows fed canola meal versus soybean meal, but no differences due to a crude protein source and no interaction. Similarly, energy-corrected milk, which takes into account both fat percent and protein percent, was very similar to the previous variable, fat-corrected milk and milk yield, where we saw about 4 kilogram per cow per day increase for cows fed canola meal over soybean meal. Again, no differences due to crude protein level or an interaction. And then feed efficiency, which is defined as energy-corrected milk divided by dry matter intake. These cows, because they were producing so much, their feed efficiencies were great. And typically, when you see levels this high, over 2, it really is an indicator that cows are probably losing weight because they're also converting body weight to meet some of the demand of milk production. All of these cows are over 2 for feed efficiency, and there was a difference in cows fed canola meal versus soybean meal of about 0.1. But overall, all the cows were doing very well. And this is kind of how that looks over time. You can see that the purple line, which is the high protein canola meal diet, those cows did have a greater feed efficiency compared to the rest of the diet, or rest of the cows. And it's really important also to kind of understand, what impact does this have on energy utilization within the cow? Are the cows losing a lot of body weight, which I'll talk about a little bit more? And what impact does that have long term in terms of getting cows bred back and things of that nature, overall health of the animals. Some of the other things that were measured components, if we look at fat percent, this was one of the few effects we saw with crude protein level. Cows that were fed the low protein actually had slightly greater milk fat percent compared to the cows with high protein, but overall the cows were very normal in that 3.9 to 4.1 range. No effect due to source, no interaction. If we're looking at protein percent, lactose percent, neither one of these were affected by any of the treatments, non-significant. If we look at total solids, we did have more total solids, which takes into effect all of the solids, fat, protein, and lactose, and ash. We did see an improvement for cows fed low protein versus high protein from about 0.25%, but no differences due to source or an interaction of the two. If we're looking at component yield, and these are really going to mirror what we saw in milk yield, because milk yield was so predominantly seeing an increase in canola meal. So consequently, in yield, we saw increases in cows fed canola meal over soybean meal. In this case, 0.15 kilograms per day for fat yield. In the case of protein, 80 grams or 0.08 kilograms per day. Also saw an increase in lactose yield. These are all highly significant. Also total solids. And I want to spend just a moment on milk urea nitrogen. I think this has been mentioned in previous presentations, but I think it's good to kind of reassess this. And, milk urea nitrogen is really a good indicator of protein utilization. And when you're looking at different protein levels, we almost always see difference in protein level. And in this case, no different. Cows fed high protein versus low protein were about 2.7 milligrams per deciliter different between the two. So you can see the high protein cows were around 12.5, whereas the low protein cows were around 10. Almost always see that. However, in the case of soybean meal versus canola meal, almost every study where it's comparing canola meal to soybean meal and probably other protein sources, we almost always see lower milk urea nitrogens. And this study was no different. It wasn't a huge difference. There was a 0.5 milligrams per deciliter difference. So cows fed canola meal were about 0.5 milligrams per deciliter lower. And this was a trend at a p-value of 0.1. So it's not as strong of a difference as we see in protein level. However, it shows up in almost every study where cows fed canola meal have a slightly lower milk urea nitrogen. And here's how it's depicted over time. You can really see the difference in protein level. The two at the top, the green and the purple lines, are both the high protein, and the red and blue lines are the low protein. That's really dominant. But if you look a little closer and look at the canola meal versus soybean meal, you can see that typically within each protein level, that the cows fed canola meal are always under, or almost always under, the soybean meal line. So both effects there. And again, no interaction between the two factors. All right, a little bit about body weight change. Really, I'm still kind of delving into a lot of this information. We did see some differences in body weight change, and very typically, cows lose weight in early lactation. These cows were high producers, so these cows are no different. You can see the green line is the high protein soybean meal line. Those cows actually had probably the slightly less change compared to the low protein canola meal diets, especially after, say, week 5 and 6. You can see that green line with the triangles is the highest. So cows rebounded very well, and by weeks 11 and 12, they were almost already back at their body weight at calving time, or during week 1, I should say. I think it's important to note that the low protein canola meal diets, that was the group that really separated themselves on dry matter intake, and consequently they also had a similar decrease in body weight compared to the high protein soybean meal diet. Took a little longer to rebound, but they did not drop as much as the other two diets, namely the low protein soybean meal diet and the high protein canola meal diet. The high protein canola meal diet, those cows produced a great deal more milk compared to the low protein soybean meal diet. So it's interesting that both of those diets ended up having the greatest body weight loss. And in the end, I think the rebound of body weight for cows fed the high protein canola meal diet took more time. They were the lowest at the end of the study, but also those cows were producing by far more milk compared to the low protein soybean meal diet. So I think we do want to formulate diets where cows are not going to lose a huge amount of weight. I think in these cases, all the cows remained healthy. We didn't have any health issues really for any serious health issues. I mean, we have the normal stuff that does happen, some ketosis. But I think all of these cows did very well in rebounding in body weight, and there really were any long-term effects. Really not enough cows on the study to determine any reproduction effects, but all the cows did well health-wise. We also measure body condition score, and you can see that in general they're really not all that different. They started pretty high at calving time, probably higher than what we'd like to see. I mean, the average was close to 4, which is quite high. And then there were some changes over time, but in general, they kind of leveled off in that 3 to 3.5 range. So in summary, canola meal significantly increased milk yield in early lactation cows. We really saw no milk response for protein level from 16 to 18%, which in early lactation was a bit surprising. I was expecting one going into the study, but the fact that there wasn't any, I think, is an indicator that healthy cows eat healthy and eat enough to meet their need, and we really didn't see any kind of response due to crude protein level. And I think the other thing to note that we saw no interactions between the source as well as protein level, which I think also is an important thing to know. Also, canola meal fed cows tended to be more feed efficient, and they were lower in milk urea and nitrogen production, which is something we see in most every canola meal study that we conduct. Now, there is very little research done on early lactation using canola meal. I think the study I just went through was one of the very first. However, just recently, Peter Robinson out of UC Davis has published a study in Animal Feed Science and Technology that is just coming out now. And you can find this online. I show the reference here. And what's interesting about Peter's work is he works with a commercial dairy farm. So this is done on a very typical California dairy. And they fed 3 diets. And on the bottom, diet, I kind of show the diet composition a little bit. Actually, I'll come back to that. The 3 diets were a high canola meal diet, included at 14.5% crude, 14.5% canola meal inclusion. And then part of the canola meal was replaced with soybean meal. So in diet 2, we had half canola meal and half soybean meal. And then in diet 3, with the concern of not supplying enough methionine, it was simply diet 2 with addition of supplemental methionine in order to bring up the methionine level. So 3 different diets. One was predominantly canola meal, the other 2 half canola meal and half soybean meal. Large dairy, I think there were over 400 cows that ended up being involved with this study. He has 4 individual pens that he uses for his studies. In this particular case, because there were 3 diets, he used 3 of the pens. Cows come onto a fresh cow diet where they're fed a common fresh cow diet. And then about day 13, give or take a little bit, cows were assigned treatments and then fed one of the 3 treatments I just explained for 5 months, 150 days. And there was a great attempt to keep diets relatively similar across the board. They were all around 17 to 17.5% crude protein. The 17% was the canola meal diet. 17.5% was the 2 soybean meal diets. They were all about 30% NDF. They were very similar in starch. The canola meal diet was about 19%, and the 2 soybean meal diets were 18%. Now you can say, whoa, that's low. Well, that's actually kind of typical, I think, for California diets. It's not typical for the Midwest United States, as well as the Northeast United States, and perhaps other parts of the world. But California dairymen use an immense number of byproducts, and I'm not going to get into the diets because there isn't enough time, but I believe there were like 6 different forages used in the study and something like 10 different byproducts. And so there were a lot of different ingredients, very typical for commercial dairy farms. So I think a real good indicator of maybe how things would work on a commercial farm versus a research farm. So I'm going to present just a little bit of data. I thought this was a good graph. This is milk yield. And the blue circle is canola meal. The orange circle is soybean meal, which is the second one. And then the gray circle is the soybean meal plus methionine. And if you're looking at production over time, the way this appears to be done is that because this is a commercial farm, the production results were from during times of DHI testing. So they were monthly analyses, monthly recordings. So you see a recording around the day, looks like around day 20, 22, something like that. And then around days 57, and then again around 83 or 4. So you can see there once a month. So in early lactation, there was definitely some differences between the 3 treatments. You can see the canola meal fed cows did quite well and were statistically different from the soybean meal fed cows. So the blue line, which is on top, and has a little A by it, indicating differences from anything labeled B or C. So in the first 2 months, there were production differences for canola meal versus soybean meal. And then by month 3, you can see all the lines kind of converge, and there were no differences during the 3rd, 4th, and 5th months. Now, if you look at the results over the entire study, here's just a brief summary. Dry matter, so these cows were pen fed, so I'm not exactly certain how dry matter intake was calculated, but they reported that the average of dry matter intake was 28 kilograms per day, and they were all approximately the same across all the diets. Milk production, there were differences, and what I'm reporting here is really the canola meal versus the soybean meal fed cows, and soybean meal was the average of the 2 soybean meal diets. And so they saw about a 1.6 kilogram per day increase in milk production over the 150 days. Milk fat percent was non-significant and averaged about 3.5%. Milk fat yield, because of the differences in milk yield, there were some differences in milk fat yield between the 2 diets, with canola meal fed cows slightly greater. Milk true protein was also very similar, but because of the sensitivity on some of these analysis, there actually was a trend for slightly more true protein on soybean meal fed diets, but 2.84 versus 2.85, that's biologically very similar. And milk true protein yield, because of the increase in milk yield, there was more milk true protein produced for cows fed canola meal. And then last, they reported body condition score, and no differences between any of the treatments, and they were all very close to 3. They concluded, the authors concluded, that substituting soybean meal for canola meal reduced performance. So when they took out some of the canola meal and put in soybean meal, we had slightly less milk performance and also milk components. And they concluded that it was possibly due to lower ruminal crude protein flow to the small intestine. And they did have some measures using urine purine derivatives and as an indicator of microbial crude protein production. And there were improvements on cows fed canola meal compared to soybean meal. So they concluded that, the rumen has an impact potentially. And I'll come back to this point in a minute when we start thinking about some explanations. But that's one that we need to think about. So I'm wrapping things up. In conclusion, we need to think, well, why, when I first started presenting the results on our own study, the first thing is like, holy mackerel, how did you get a 4.5 kilogram per cow per day increase? And we need to start thinking about what some possible explanations are. We're still analyzing some of the blood work yet on amino acids, so we're hoping to get that done soon and to help explain some of the potential differences in amino acid profile. We spent a lot of time talking about amino acid profile, and certainly we still believe that is an important explanation. But does it explain everything? And it's likely that it doesn't. Certainly increases in methionine are very important in early lactation and during the transition period. So I fully expect that that increase in methionine has an important role. And we'll continue to investigate that particular area. But are there other potential explanations? Reality is the difference in milk production due to dry matter intake really only explains about 1.5 kilograms of the difference. And we still have another 3 kilogram difference increase to explain. And so the increase in methionine is one potential explanation. Another potential explanation that was just talked about from the paper out of UC Davis is that there could be improvements in ruminal outflow of microbial protein. And you know, canola meal is an interesting feed. There's carbohydrate sources there that can be utilized by microbes, the fiber, and I think there are things there to investigate further on how we may see improvements in ruminal microbial protein production in the rumen for cows fed canola meal. So that's another possible explanation. Now, because this is interesting and there's a lot of questions yet still remaining on trying to explain why we saw such a big difference, we are underway on following this up to understand further if canola meal has an impact in the dry period. So we're adding an extra layer on the previous experiment and looking at canola meal versus soybean meal in the dry period to understand if that has a carryover effect. And again, a very similar study where it's going to take us 9 to 10 months to complete with 80 cows. And we're really looking forward to understanding more on why we saw such good results on feeding canola meal. But I think the evidence suggests that because of the profile and potentially some of the benefits in the rumen, that cows fed canola meal really do extremely well on those types of diets over some of the other traditional feeds that we're using at this time. So with that, I would just like to thank some of my lab members. Diane Amundsen is my technician, who I really would not be able to complete work without her assistance, along with 2 graduate students who are currently working on these projects, Spencer Moore and Jordan Kuhnel. And I also would like to thank the Canola Council of Canada for helping support this work, as well as USDA. So with that, I would be happy to take any questions that you may have.
Okay, thank you, Dr. Kalscheur. While we switch over to our slides so that you can ask questions, please put any questions that you have in the question and answer window or in the chat window. In the meantime, I'm going to go and share my screen, and Brittany will talk a little bit more about Canola Council, and then I'll wind it up with some information about the nutritionist webinars, and we'll begin with questions. So Brittany, go ahead. Just tell me when you are done, and I'll forward through this slide.
Sure, thanks, Marion. And thank you very much, Dr. Kalscheur, for that great presentation. I just want to very quickly here highlight a website that you can go to for further information. So we have the website canolamazing.com, and you can see that link down there. Within canolamazing.com, there's plenty of different resources, and there is also a canola meal feeding guide. And so in that feeding guide, we always have, we update that to include lots of different research that has been done, and definitely Dr. Kalscheur, his research is highlighted in there, as well as any research from Dr. Antonio Fasciola that you heard on the previous webinar as well. So yes, please do head over there to find any more resources. Okay, Marianne, back to you.
Thank you, Brittany. Yes, and for those resources, we also have the last 2 Canola Council webinars on our website. That would be agmodelsystems. One of the things we have done in recognition of how much time nutritionists used to spend driving to farms, and I'm sure that will come back, is we've put the webinars into podcasts. You don't get the benefit of looking at the charts, but if you are like me, you listen and learn and listen and listen and listen. So this enables people to download those podcasts and listen to them while they're driving instead of whatever they may find on the radio. I do want to remind you of our nutritionist webinars that are coming up. We hold them the 2nd Thursday of every month, February through November. We try to make it so that it's all inclusive for as many places around the globe as possible time-wise. So we have a 9 a.m. Eastern Daylight Time webinar. Our next one will be June 11th with Dr. Jude Capper. She is a livestock sustainability consultant out of the UK, has done much of her, some of her education and her PhD here in the US at Cornell University. Her subject is going to be Back to the Future. What has the US dairy industry achieved since 2007? And what we have to focus on to move forward? Once our countries do all emerge from this quarantine and life gets back a little bit to normal, I'm sure that the discussions of the economics of the planet will come to the fore again. And Jude has some interesting information on that. So without further ado, as is the saying, we'll go ahead and move to questions. If you do have questions, please put them in the chat window or the Q&A window. I will not be unmuting anybody so that they can ask questions. Right now, we're waiting for a few to come in, but I imagine Essie, with her depth of knowledge, probably has some that she could ask Dr. Kalscheur to elaborate on the points that he made. Dr. Kalscheur, I'm going to go to the slide view so that if you need me to navigate to a given slide, you can easily point out which one I should go to in an explanation.
Sounds good.
All right. Essie, I'm going to put you on the spot. Do you have some thoughts?
No, I thought that the presentation went very well. Thank you, Kenneth. Your opinion of early lactation trials, like there's some difficulty in doing them. I think that you found some items that haven't been found before with regard to canola meal. Like we were basically conducting mid-lactation trials, and yours really stands out as the first one that was quite different. Were you surprised by the magnitude of the difference in the results?
So, I did not expect to see a 4.5 kilogram per cow per day difference over a 4-month period. I mean, that's quite dramatic in my opinion. But I think it's also important to note that there is a lot of variability in early lactation. So you need, I think there needs to be, strong differences. I think it really points out the need for enough animals in studies. Yes. And I can say and look at, 80 cows, that actually was the largest study that I ever had actually conducted at that point, because most of the time we just don't have that many animals available to us. And I think that's a challenge for all of the researchers if we're dealing with, herds that are 100, 150 cows, research herds. To get 30 to 40 cows is actually considered pretty good. But I think it's important to note that in transition cow work, that because we're not using as strong a covariates, there's no common feeding period, that you have to have enough animals in the study. And I think 20 per treatment with 80 in total is adequate. And we were able to show strong differences because of those numbers. So, so that's one aspect when you think about doing studies. Certainly, if you get out in commercial settings, you may have a lot more animals, but you also have a lot more challenges that, when Peter does those have other challenges because you can't control a lot of the outside factors that we can do in research herds. So, when I think about the study itself, I think 4.5 kilograms, I was surprised that it was as great as it was, but I think the data is very solid. I mean, it was very pronounced between the two. I think the two sources. I also think that, the time, because some studies are shorter in length, this one being 4 full months, really demonstrated that there was more of a long-term effect, that all the cows didn't just kind of come back to the same production level.
Yeah, and I think it was interesting that your results and Dr. Robinson's results, where he only replaced half of the canola with soybean, he seemed to get about half of the amount of milk that you did.
Yeah, and that easily could be one possibility. One difference with his is they kind of came back together.
Yes. In
terms of production over time, but there was still a pronounced difference between up to the 3rd month. So I do think those two studies do kind of work well together and explaining some of the differences.
You're now doing more work in fiber. And you
Yep.
mentioned that you feel that there might be some differences with respect to the NDF fraction that could be affecting microbial growth. Are you planning on doing anything? Go ahead, I interrupted you.
No, you finish your thought. Planning to do anything in?
To look at that a little bit more closely, to see if there's some aspect that we haven't yet discovered that might be related to the microbial component. Yeah,
so I kind of cut my teeth on byproduct utilization, and we did a lot of that in South Dakota State, including work with canola meal. And one of the tasks that I have here at the U.S. Dairy Forage Research Center is part of its name, and that is utilization of forages and fiber, and really trying to utilize feeds that are not going to be in direct competition with non-ruminants as well as people. And we really need to find better ways to utilize fiber sources that are available to us. Part of that is increased fiber utilization in forages, but also in the byproducts that we have available to us. And canola meal, I think, is a great example of a feed that has more fiber than maybe most of us think about. And, it's usually 25 and greater in NDF. And so there's a good energy source available in canola that I think sometimes we overlook. And it makes it a really good ruminant feed, in addition to the amino acid profile that we talk about a lot. And I think there really are some unknowns yet in feeding canola meal and carbohydrate utilization that have not been well elucidated at this time. And because we know that there's a good amino acid profile in order to produce microbial protein and also supply amino acid to the cow, the energy provided through potentially digestible fiber and potentially other energy sources in the diet, I think are a really good blend so that there are improvements in microbial protein synthesis. I think there's limited information on this. This was one of the hypotheses posed by Peter's group in California that, and I've had discussions with people here as well years ago where there's thoughts that there could be a better synergy in microbial protein production because of some of the carbohydrate utilization. And I just don't think we have well investigated that just at this time. I think that's an area that probably needs some more attention. But I think those explanations of a better utilization of the protein to convert it. So what's great about canola is we generally see more amino acid supplied to the small intestine because it's more protected. There's greater rumen undegradable protein in canola meal versus soybean meal. But there also appears to be a potential greater production of microbial protein synthesis. So rather than it being degraded and going across the rumen wall and being excreted in urine, it's actually being utilized to a greater extent by both the rumen microbes as well as the cow. And I think that's also likely part of the explanation.
Thank you. I think, Marion, do you have some?
Yes, I do. Thank you, Essie. And certainly if you feel there's an opportunity to elucidate on some thoughts, that would be fantastic. I think these webinars work really wonderfully when we get an exchange of ideas in that way. In regards to some of the statements you made about the protein and the energy that we don't quite understand, what is your suggestion in using canola meal in a calf starter to boost growth? Do you have any experience or thoughts on that?
So I've asked myself that question, but we have not investigated that. I remember when I was still at South Dakota State, we were doing calf research, and that was something that came up. It's like, I wonder how it would do in calf starters. I have no reason to believe that calves would not do well. I mean, I think you could easily replace soybean meal for sure if you're using much in a calf starter. We did actually quite a bit of work with distillers grains in calf starters, and that was successful as well. And that does not have as good amino acid profile. So certainly I think in a calf starter, canola meal can easily be included, as long as it's a high quality canola meal. Because you don't want anything that's going to decrease intake. So intake's important. And most of the canola meal that we're getting here now is excellent in quality. I really don't know any situation where canola meal couldn't replace other feeds, whether it's calves, heifers, dry cows, lactating cows. I mean, all of the studies that are really coming out show that it's going to perform similar or better than alternative protein sources. One last comment is I'm not aware, and somebody can correct me if I haven't seen it, but I don't, if there is a study on feeding canola meal to calf starters, it's like there's one or none. I can't recall if somebody may have put one out recently, but I know if you look back over the years, there's been very little work done in that particular area.
The only one I'm aware of is some work that Greg Penner did. And I think that they're with the very, very young calves, there was an effect on intake. And so he recommended feeding it, like after about 8 weeks of age or something, when they're a little bit.
So decreases in intake, the taste. Yeah. Yeah, that one surprised me because certainly at that age, we don't want to diminish potential intake. So I would definitely think about that. But in most cases, in most animals, the canola fed animals have done extremely well in intake.
Well, they did great on the grower phase. So there was no issue there at all.
So this is sort of post-weaning recommendations rather than as still a neonate.
The starter is before weaning.
Right.
The grower is after.
Okay.
So
that makes a lot of sense.
Yeah, a little bit. They're still on milk and trying to transition off, and that's a little bit difficult in that period. Right. And there's always is that discussion of the advantages of maybe accelerated and large amounts of milk and also balancing that with starter intake. So it makes sense that anything that may decrease palatability in that young age is something to be cautious of. Yes.
Another question on the farm level, if you just simply substitute soybean meal with canola meal, diet crude protein might be slightly different. What would the response be in milking performance?
So it's highly dependent on what your protein level already is, before doing that. And I will say, I remember 5-6 years ago being at ADSA and discussing this exact question, and people saying, yeah, I swapped 1-for-1 canola meal with crude protein. Cows didn't drop milk production at all. And I think in many cases that absolutely can happen. However, you have to be aware that canola meal is around 40% crude protein, whereas soybean meal is around 50%. And so depending on where your diet is balanced, you have to make sure that you're still providing the amino acid supply required for high production. So if you're balancing your diet right on that line, where you're near, a deficiency, replacing 1-for-1 may not result in exactly the same milk production, but chances are, and I would say 9 times out of 10, if you replace 1-for-1, you're probably not going to see a negative effect. And if the amino acid profile is improved, you may actually see a benefit of doing that. So I think the take-home message there is really to understand the diets that you're currently feeding and whether or not you're meeting both the nutrient amino acid requirements of those animals and whether or not you can actually swap the diet out 1-for-1. And if you can, that will likely lower your cost of your diet because you're replacing some crude protein with something else. You're not feeding, if you're taking out some soybean meal, which is typically a little more expensive, you may be able to lower the cost of your diet. Of course, that depends on what the costs of all the individual feeds are, but that goes into the decision-making on how we formulate diets.
Okay, thank you. Another question, considering that canola meal is available in other countries, do you foresee the advantages you've seen in your research applying to dairy operations in other countries where feeding ingredients and quality may vary? So that sort of gets to the discussion of where's the canola meal from to some extent.
Yeah, I think this is true with really all feed ingredients. You really have to have an understanding of the nutrient composition and quality of the feeds that you're feeding. And I agree that, you know, I think canola meal, much like other things like distillers grains, can vary a lot. So it's really good to have an understanding of where it's originating from, what the quality standards are from the production plants. I think the canola meal that we're working with, either out of Canada or northern US, are very good, high quality. And the other thing that I think was brought up in earlier presentations were that, you know, the term canola meal really refers to some specific varieties of rapeseed, and that people do interchange the terminology of rapeseed and canola meal. And while canola meal is rapeseed, not all rapeseed may be canola meal, in the sense that there are air quality differences and there are variety differences out there. So you have to be aware of the type of canola meal / rapeseed meal that you're using, and understand, are there high levels of glucosinolates? What's the protein level? Are the amino acid levels different? And so it's important not just to take a book value, but to really understand the nutrient composition of the feeds that you're trying to utilize.
I know that with our program, so much of the CMCPS model is really honed in on those feed analyses, and it's important to get, while you're using library values when you pull in feeds, and specifically in AMTS, it's so much better of a complete analysis if you do send your feeds off for analysis, so that you're capturing the regional differences. And to that effect, we try very hard to encourage people to use regional feed banks.
It's, you know, I can't really stress that enough, because we're going to be able to formulate diets better if we have more knowledge about the feeds that are going into those diets. And I know it's easy for me to say, yeah, analyze all the feeds. And when you're going through so much feed, it gets expensive really fast. And so you have to really be judicial in understanding which feeds to analyze, have an understanding on, you know, how is it a feed that varies a lot. So if you're getting corn grain and it's consistent, you're getting it from a similar source, yeah, that's typically one we don't analyze. But when you have new crop coming in, sometimes it's worth analyzing to see if it's different from the previous crop. Obviously, forages we can't talk about enough in terms of nutrient analysis, because they can vary so much. So those are typically things that we analyze. Now, byproducts fall into that a little bit. It's like, is it a byproduct that varies a lot? Some do, some don't. And I think in some cases, when distillers grains started becoming popular, we saw huge variability. And so understanding the quality of the feed is really going to help us determine how to formulate the diet. And so, yeah, you may not analyze, you're certainly not going to analyze, you know, every sample that you feed every day. But when you have new loads come in, you know, it might be worth, if it's a big load of feed, that you can analyze once through that feed. And I realize some of these dairies go through feed so fast that you're not, by the time you get your analysis back, the feed's gone. You know, it's already been utilized and fed out. So you have to have I think what you have to do is you have to do it enough to get an understanding of the variability that you're dealing with, so that you can formulate a diet with that variability, and try and do it as often as possible. But anytime you get nutrient analysis, it's going to help you formulate the diet.
Would you say advances that they've been making and continue to make in NIR technology is really helping that efficiency, quickness, and contributing towards making it less expensive to do frequent analyses?
Absolutely. I mean, I do think that's one area that probably doesn't get enough attention. I mean, we know it's out there. It absolutely is quicker. It absolutely is way cheaper. So yeah, I mean, you can get results very, very quickly. And so I think that probably is something that eventually is going to be pretty standard almost. I mean, because having some idea on nutrient composition is always helpful. And when you have new trucks coming in, if you can do a quick analysis with NIR and have it, in minutes, or at least 30 minutes or less, I think that is very beneficial with getting a more accurate diet in front of the cow.
Well, and correct me if I'm wrong, but isn't it the more analyses we do, the more accurate those NIR the information gets, because it actually feeds into their databases to be able to make sure that they're calibrated correctly?
Yeah, I think that's a good point to bring up. So NIR is only as good as a database that goes into building the equations to predict the nutrient analysis of the feed you're analyzing, if that makes sense. I just kind of rattled that off. But so what that means is, if you have an NIR machine, but no database, no wet chemistry, you're not going to have good predictive equations. However, if some of these labs have been doing nutrient analysis for decades, and they have built up excellent databases that can predict predict nutrient composition using NIR from these wet chemistries that are typically for a specific geographic region. Now, our goal is to have very robust equations that we could analyze everything, but the reality is, if you have a lab, in New York that has predominantly feeds from New York, the equations are going to be best for forages from that region. And that's true anywhere, right? Whether it's in Wisconsin, California, etc., in India or China or wherever you are, using feeds to build a database from your region are going to give you the best predictive equations. The reality is, though, we're getting feeds from all over, so sometimes you can build more robust equations. But the comment you made about building databases is really critical on getting good results from NIR. You need databases that have a lot of data and a lot of different wide ranges of data. Like, say, forages, for example, you have poor forages, high quality forages, and everything in between will give us a better predictive equation than if that range is really narrow. So I think some of these labs have made vast improvements on that. And I'm not an expert in NIR, but I think labs that have been doing analysis for years and years and years probably have very good predictive equations. And it's a good way to come up with really quick results. You can typically send in a sample overnight, and by the end of the next day, you have results back. Now, I think in the future, and this is probably already happening in some places, you'll have one on the farm, and so you'll do those maybe yourself.
Yeah, I think that especially the NIR companies are also pushing toward that too.
Yeah, absolutely. There's some that are pushing the home model.
Well, and in some cases, isn't it sort of a balance? You do more complete analysis, wet chemistry, perhaps on the first analysis you send in, and then if your source is similar, you follow up with NIR?
Yeah, I think you want to make sure that you're confident in your NIR equation or your results. So, I mean, I use NIR for kind of quick testing, if I need a result pretty quick, and to confirm what I think I have. So that still means I'm doing wet chemistry, and any of our results that we publish, and this is kind of a stickler point between the animal people and the forage people. I talk to a lot of forage people, and they're like, why don't you use more NIR? Because in their world, NIR is fully accepted. There's papers that only do NIR, and they don't necessarily do any wet chemistry. In our case, for animal studies, we still rely pretty heavily on wet chemistry because we're less confident, perhaps, in some of the NIR results. I mean, typically there is a little more variability with NIR, but it also really depends on the equations that we're used to build at. And most of those, if you're sending to a lab, are proprietary. I mean, you don't have your own equations. Now, if you're buying an NIR machine from a company, I'm assuming they're providing the equations. And so hopefully those equations are relevant to your feeds. Meaning, if you're buying a machine from Italy, for example, are the equations appropriate for feeds produced in India? You have to ask that question. Maybe they have a separate database for feeds specific for that region, which is probably the likely scenario. But it's really important to understand the database, the feeds that go into the database, and whether or not the equations are going to predict the types of feeds that you are wanting to analyze.
While we're still discussing NIR, and perhaps Brittany and Essie might weigh in on this, they might have some insight. Is there any particular model that is best applied to canola meal without like being, I don't know, telling only by this kind? An unsolicited sponsorship.
I think that it's based on the lab and how good the lab analyses are that go into making up the equations. And generally, each season you need to generate new or modify your equations based on the, the profile of the ingredients that come in. So if you're using last year's information for alfalfa, it might not be as accurate as newly generated information.
All right. Very good. Thank you. Thanks. Dr. Kalscheur, anything to contribute, or is that pretty well what Essie summarized?
I agree with that. I mean, I have no opinion on brands or anything like that. And neither can I really say anything as a representative of USDA.
Right.
However, I think there's a lot of good brands out there. And I do, they're only as good as equations. So the databases are always being updated. I don't really know if they start over each season or if they just continue to add to the database. That part of the database, I don't really know how they do it. But I'm assuming that it gets added to, newest analysis gets added so that you're building a more robust database. But I think it is valuable to have feed that are part of that database that are relevant to the feeds that you specifically are using. So, for example, if I had Bermuda grass out of Florida and send it to a lab in the state of Washington, I don't know if they would have equations that would be appropriate. So it's really important to use the right lab that are feeding or that are analyzing those types of feeds that can adequately or superiorly analyze those types of feeds.
Yeah, and just to reemphasize the point that you made that regionality is pretty important. The same is true of even the models and how they work. For another question, do you have future plans for research to continue to work towards understanding the response of canola meal in dairy diets and specifically early lactation?
Yeah, so we actually have a study underway right now to follow up the results that I presented. And this, the study that we're currently doing, and we're about halfway through, the study is designed to investigate the impact of the dry period. So whereas the last study I explained really started at calving, this study starts a month prior to calving, where we're including two types of diets, one with canola meal, one with soybean meal, to investigate how canola meal may impact future production, but starting 28 days prior to calving. And I think this will help explain our previous results and also further demonstrate whether or not the dry period has an important role in future milk production, which I think the answer to that is yes. And we'll be able to further elucidate some potential mechanisms by some of the sampling that we're doing. We'll be looking at liver biopsies and other interesting types of analyses that I think will help explain some of the results that we saw in the first study.
Okay, thank you. And unless I get further questions, I think that we have asked all the questions that were in my queue. And Dr. Evans, Brittany, I want to thank you so much. Dr. Kalscheur, it's been grand. Thank you for participating in the webinar. And as I said, we are going to re-record Dr. Evans' introductory statements because we were dealing with a little bit of problems with the connection. She says people are digging up in her road. So we'll get that recorded and I'll just dub it in over top of the initial presentation. I hope to have the recording up in the next 24 hours, but sometimes I get distracted. So it definitely will be there by the end of the week. All of you who were attendees, you'll get a notice telling you that the archived copy is available. So.
Thank you very much, Marianne, Dr. Kalscheur, Dr. Evans. Thank you for great presentations today and coordination of the webinar.
Yeah, and thank you everybody for attending. This has been fun. All right, and I will include links in that email to the other webinars as well, just so that you have, it's just a click away. All right, thanks everybody. Thanks for joining us this morning for us. today for whatever time of day it is for any of you joining. Have a good day, and unless I get any more questions quick, I'm going to close out the webinar. All right. Thanks, everybody. Have a good day.
Thanks.